This is kind of a miscellaneous idea kind of thrown in here for solving uh, rational equations, I guess you'd say, that are formulas. It's a big idea in physics or chemistry. It's one of the big applications of math. So we have an equation here, and what we want to know, we're going to leave all these things as I don't know, and we want to solve for t. So the trick is we're going to treat everything else except the one we're interested in as if it was just a number. So this is a very strange equation here, but so if t is what I want to get alone, then and everything else was a number, do you see what I'd have to do here is I'd have to multiply both sides by t. So then I'd have 3 equals 6t, and then I would divide both sides by 6. So if you're ever not sure what to do, I literally will make myself a practice one over here with numbers in the place of everything but the one we're looking for. And then I'd say, well, okay, well, how would I do that? What would I do next? Well, that's the same here. So we're going to follow that same pattern. So I need to move him up to the other side. Okay, so that would leave me with this. Now, if I have something in front of t, if it was 3t, I would divide them both that away. Okay, so I will. So they'd cancel down. Now I'm going to write it the other direction, but d over r. So again, the trick here is, and I have this earlier, I think in an earlier video too, but for this portion, what you want to do is treat everything else like it was a number and say, okay, well, what would I do? T's down here, I'd need to move them up. I'd need to divide the 6 across. Well, let's do the same. Alright, so we're going to try the same here. We want to do this for L. Well, everything else is a number in my mind. I'm going to multiply both sides by L to move him up. Okay, now I'm going to do it, I always do it like this. The one I'm looking for, I want him at the back, because that shows me, like, if this was 3x, I would divide by what's in front. Well, we're going to treat that like it's a 3, so we would divide it. So, all right, now, if this is, I'm going to write it the other way around just because we like to do this. Okay. Now, same thing. These are going to get harder, but we're just doing the same thing again. So I'm going to jump ahead if you see this. So these are going to wind up switching places. That's what you're going to do. You're going to move him up. You're going to move him down. Okay, now this is a much more complicated formula. This would be a slope formula. This is actually how you do the point slope formula, where it comes from. So all of this needs to be treated like a number, because we know that this is like a factor down there. It's all together because of the minus. That is all one number. So, well, what would I do? Well, the first thing is I have to move all of this at the same time. So I don't know. Let's see. Can I use theirs? Yeah, actually I can. So they've multiplied both sides by the y minus 3. Okay, those would cancel. Now I have this up here. Well, what next? Our goal is to get y by itself. Well, let's distribute. So, oh no, not on this one. I'm sorry. What we'd want to do here is let's divide both sides by the m. Okay? Oh, they did distribute. Well, you could do this either way. So let me pick it up here. So this was my first idea. I'm going to send this m through. Okay? We get ym minus 3m equals x minus 2. Okay, we want to get y by itself, so I'm adding 3m to both sides. Now, I've got something here with the y, so think of it as if it was 3y. I would divide it away. I know it's written on the back here, but you're still just going to divide it away. And if you divide it from one side, you have to do it to the entire other side. The whole side. Okay, now don't think you can cancel this m into this m. It can't. If you wanted to divide this, you'd have to be able to put it into each of these 3 terms. They're separated by pluses or minuses. I'd have to go into that, that, and that. And it could be written that way. It's not any more helpful, so we're just going to leave it right here, where the m can't go into those two, so we're just going to stop. Okay, try a similar one here. We're trying to solve for x. Oh, I know what I want to show you. Could I have done this on this one? Well, let me show you this here. It's kind of a hodgepodge of ideas, but do you remember if you had a proportion set up where you add this over this equals this over this, you would do a lasso strategy. And you could just multiply the lassos. So I'd have 10 equals 3x. Look how easy that would be. Well, this is set up where I have a number over a number equals a number over a number. This is a proportion. So I'm going to lasso those. I'm going to lasso these. So I'm going to have 3 times y minus 2, which you can no longer read because I've covered it in my scribble. So this is the fastest way to do this problem. I'm going to do these proportions. Now, let's distribute here. I get 3y minus 6. Now, our goal was to solve for x. So if I want to get this alone, it'd be what it's always been. I would subtract away a 2. Now I've got something in front of x. Do it on one side, you have to do it to the entire other side. Now I'm going to write this the other way around because x's, those are gone. Okay, now here's something you're familiar with because you've done slope before. You could send this to, but he's got to go to both of them. I could write this. I sent the 2 to both of them. Now, that's not really accomplishing much, and this is not really a line here. So I would probably just leave it like that. But they're both equivalent answers. Okay, if you can see where this is, try it, but I'm going to set this up as a proportion. So I could then lasso. I just made x over 1, which is the same thing. Now I'm going to lasso these, and I'm going to get 1 times y as y. All right, this I think is going to have a little trickier math. Let's distribute this. Now our goal was to get y alone. Well, they're in both rooms, so I'm never going to get them alone like that. So what I'm going to do, this whole group has to move. That's x, y. I got to send the whole thing over. So I've got y plus xy equals x. And now I had to do that to get all the y's in that same room. Now what am I going to do now? These are not like terms. They can't be joined together. Well, the trick here is pull out a GCF. Okay, now this is a number now. 1 plus x is a number that can be divided away. If you do it on one side, do it on the other. And there you go. Now we have a little different idea here. This is finally going to resemble what we've been doing over the last few days. So I'm going to make this a fraction on the end there. Now we want to solve this for c, but this place to start here is we are going to get a common denominator across all of these. He needs an m, so I'm going to give it to the top. He needs a c, so I'm going to give it to the top. And he needs MC. Okay, same thing we've been doing. If this denominator is now a match, it doesn't matter anymore. And all we need to worry about is the top. So we've got some tricks here. It's actually going to be the trick we saw in the last one. We're trying to get C alone. So I'm going to get all the C's in one room. I need to stop writing these ones. I'm going to fix that because it doesn't mean anything. Okay, now our trick in the last one was let's pull a GCF out of here. Do you see that? They share a C. So I pull that out. Now to get C alone, I'm going to divide both sides by m minus 1. I'm going to flip it around here. This is what you would get. Okay, one thing I noticed as I'm flipping through, now they're telling us a restriction here is that m can't be 1, but that would be obvious. So I don't think I would want you to write that, but they're just pointing that out. Okay, try one on your own if you want to. Okay, made that a fraction. So he needs b, he needs a, and he needs a and b. Yeah, which is a little silly here because we're making a word up here. Okay, so the bottoms match. They don't matter anymore. I'm not going to write 1b. I'm just going to do b plus a, and let's make this abc. That's fun. All right, now what are we trying to get alone? We're trying to get a all alone, so let's get all the a's in one side. Just subtracted him over. Now, this is the trick we've seen in several of them here. I'm going to pull out a GCF because they don't combine any other way. Now, let's divide both sides by that. So I'm taking that whole thing in the parentheses and dividing it across. Okay, there's only one more. Let's go ahead and try it. All right, so a common denominator here is a little more complicated. He needs a 3 and a y. He needs an x and a y. He needs a 3 and an x. Okay, their denominator matches, so I'm just going to let it out, let it go there. I don't need it. And I don't want to show the ones just because they make it a little more confusing. Okay, so that's what I got. Now, we wanted y by itself. We've already got the y's in the same room and they can't combine, so we're going to use that trick we've been doing with the GCF. Now, everything in the parentheses is a number, so I'm going to divide it over. Okay, that's kind of a miscellaneous kind of section, but it's really valuable for, like I mentioned, chemistry, physics, other sciences, mathematics, of course, as well, to just solve an equation for a variable using some of the tricks we've learned for rational expressions.